So we are being asked to solve x plus 5. Well, that came from that parenthesis, and then x plus 4 came from the second one. So now we're just going to solve. So I'm noticing we're setting them equal to 0. So to solve, I want to isolate x, and I'm going to use inverse operations to do that. And when I look over at my example over here, I notice that they did the same thing. So when I look at my example, I see that x plus 2 equals 0 became negative 2. Well, that makes sense because they must have used opposite operations or inverse operations to move the 2. So I'm going to do the same thing over here with 5. So the opposite of plus 5 is minus 5. So I'm going to bring my x down. 5 minus 5 is 0. It's gone. And 0 take away 5 is negative 5. I'm going to do the same over on the other equation. I'm going to subtract 4 because it's the opposite of plus 4. So we're going to get x equals negative 4. So what is the solution for each equation? Well, the solution is x equals 5, negative 5, and x equals negative 4. So what do you notice about your solutions in the graphs of the equations? Well, in the first slide, we noticed that x plus 4 and 5 were the same as the intercepts, right? We had intercepts at negative 4, 0, and negative 5, 0, but we wondered why were they opposite values? Well, now we know. Once we solve each of these, so we solved x plus 5, and we got x equals negative 5. We solved x plus 4, and we got x equals negative 4. Well, now they match, right? So what can we say about x minus 5 and x minus 4? Well, we notice that they're the x-intercepts of the quadratic function. So we've just learned how to solve for the x-intercepts, the zeros, the roots, the solutions, whatever you want to call it, of a quadratic function. And we did that by setting each of the factors equal to 0.